Hi everybody, welcome to another video in Math 1332, section 5.5, the real numbers and their properties, block addition. Throughout this chapter we talk about different subsets of real numbers. Now let's review. Set real numbers consists of the union of rational numbers and irrational numbers. Okay, we'll get to that in a minute. Now let's just review. The natural numbers is the set of counting numbers. So this is called a counting number. The whole number, those counting number, we're going to add 0 to it. So we're going to add 0 to it, to something we already have, just add 0. And so this is set called a whole number, so just add 0 to it. The integers, what we add to it is all the negatives. So we have counting numbers, add 0, whole numbers, add all the negative, integers. Rational numbers, of course everything here, and we can say anything can be put as a fraction. So I'm not going to say this, so just say fraction. If we write in decimal, so it is terminated, or repeated decimal. Of course, if we want a fraction, we can say it negative 3 over 1. So that is a fraction or ratio. So we can say that is rational numbers, even though it is also an integer. Right. Irrational numbers. Irrational number is something that cannot, it's not terminated, nor repeated decimal. So we say decimal. That are not terminated or repeat. So rational and irrational number are completely different things, and real numbers equal the union of rational numbers and irrational numbers. So we just say real numbers is rational and irrational numbers. Now if we draw a Venn diagram, we have something like this. The natural numbers inside of the whole numbers, inside of the integers, inside of rational numbers, and then rational numbers and irrational numbers are two different things. Combine them together, we have real numbers. Right. Before we continue, I just want to elaborate a little bit on this quote. It said, natural numbers were created by God, everything else is the work of man. So originally we just have the counting number, and if we add them, it is still a counting number, so that's good. Now if we start to subtract, there's a number 0. Number 0 is not the natural numbers, so we have to add to it to have the whole numbers. So there we have whole numbers. Now if we subtract the smaller number to a bigger number, we have negative 1, and because that is new, that is not the whole number, so we have to make the set bigger, so that's called the integers. Now with that, we can multiply 2 times 3 is 6, negative 1 times 5 is negative 5. So all of the product of rational numbers, all the product of integers are integers, which is good. Now when we start to divide, that's where we see a problem. This is not an integer. So in that case, we make the set bigger and we include all the fraction and we make that rational numbers. Of course, when we have rational numbers, there's something that is not terminated, not repeated. So that irrational numbers. Right. Next, classify each of the following according to the type. Of course, 0, not the natural numbers. So we have it is whole number. And also integers because that the set inside integers. And then rational number. That's it. And then of course also real numbers. I forgot that. So that's where those set belong to. Right, next we have square 15. And for this, I'll just have one theorem here. If n is a natural number, then square root of n is either a natural number or it is an irrational number. There's nothing in between. Right. So square 15, it does not come out nice and even. Square 15 is prime. So square 15 is not an integer or not natural numbers. So in that case, it have to be irrational number. And of course, that also real number. Right. Keep going. Negative square root of negative 3 over 4. Well, it is a fraction for sure, so it's rational number. And also real number. This one repeating because of the 6 repeating, so it is also rational number. And of course real number. Right. Next we have this example. Classify the following into sets of real numbers. So there may be more than one. Right. Now we look at all of this. What are the natural numbers here? We know it's not going to be negative. 2 is a natural number, so it's good. 0 is a whole number, so 0 is not. 2/3 fraction is not. Square 25, it is equal to 5, and 5 is natural numbers. Therefore, square 25 is also a natural number. 12 over 3, that is equal to 4. So that also natural numbers. That repeating decimal, so it's not square 3, it's not square 2. Pi is not. I just want to put square of negative 2 here. This is defined to be imaginary. So pretty much anything that is negative inside square root is imaginary, right? So, but as far as the natural numbers go, that's all we have. Now the whole numbers, we're just going to add an extra number to it, meaning the 0. So we already have this. Just going to add 0 to it. So we can just close out all those numbers. Next, the integers. Integer we have all of this, because natural numbers is inside whole numbers. The set of whole numbers inside integers, integers inside rational numbers, and irrational numbers is completely different things, but combined together we have real numbers. Anyway, so integers we have all of the thing above, and the new number to that is -3. Right? So just make the set bigger and bigger. Our rational numbers will be all this number. And then what new is there's a fraction. I'll repeat decimal, so those are rational numbers. Of course, on the one of the section we can write this as a fraction, right? So that's rational number. Of course, what left are those two, which is irrational number. And then put all of that together, rational numbers and irrational numbers, we have real numbers. We're just going to write down everything. Right, so that's what we have. Right, next we go over some properties of real numbers. So closure properties. The closure properties is that if we have two numbers, add them will be inside the set. So kind of like what we have here. 1 plus 2 is 3. So natural numbers is closed under addition. Closed under multiplication is where we multiply two numbers, we get a number in the set. Commutative, changing the places in the product or in the sum. Associative properties. So the order of the numbers ABC stay the same. The only difference here is we change the order we evaluated. This is A plus B first, then we do B plus C first. But either way, the same thing. We have the same result. This is called associative properties. And then identity properties is there is a number. When you add something to that number, it remains the same. So we write this. We have, for example, A plus 0 is equal to 0 plus A is equal to A. So any number plus identity is itself. Same thing as multiplied by 1 is itself. Inverse properties. Inverse property is when we multiply a number or add to that number, we get to the identity entry, identity number. So A times 1 over A, which is 1. 1 is identity. So A and 1 over A are inverse of each other. 1 over A times A is equal to 1. I don't know why I copied the same thing. But I should say -1. Actually, it's not the same thing. Okay. One is this order and the other one. Yeah, it's just commutative properties here. What I'm trying to say is we have this, which is the inverse properties of addition. We have a number plus the opposite equal to 0, or opposite plus A equal to 0. Either way, they are inverse of each other. And the product equal to 1, the identity number. so they are inverse of each other. And last, we have distributive properties. So I just multiply it out, if you will. Right, the last part of the section, we briefly go through what we call the clock addition. So a clock addition is just adding in the clock. For example, we said 2 plus 3 equal to 5, meaning that at 2 o'clock, if we rotate 3 more notch, 1, 2, 3, we have 5. Next, 4 plus 5 equal to 3. So we're starting from 4 o'clock, we go to 5, tick, 1, 2, 3, 4, and 5. And when we add them, we just go round and round to it. 3 plus 4. So from 3, we go 4 tick, 1, 2, 3, 4. We get back to 1. So in the clock, when we add, we just keep going back. Keep going round and round, going back. And we define that operation. We make into a table like this. So verify that it is closed under addition. Now it takes a lot of time, but if you take any two numbers, we add them, it will be inside. It's still inside the clock. So it doesn't matter how many numbers we have in the clock. When you add numbers, just go round and round inside that clock. So it's certainly closed under operation, the addition, whatever that operation we define. So of course we can verify that, but just saying that doesn't matter how many ticks that we add to it, we always get a numbers in the clock, on the clock. The identity properties, we can say 0 plus anything is anything plus 0 is itself. So 0 is the identity here. And identity inverse property, so we can say A, if you add to negative A, is equal to 0. But the negative is defined a little bit different. For example, look at the clock. If we add 1, we have to turn 1, 2, 3, 4, and 5 tick to go back. So say 1 plus 5 is equal to 0. So starting from 1, we'll add 1, 2, 3, 4, get back to 0. Add 5. Then 2 plus 4 is equal to 6. 3 plus 3 is equal to, 0. And then 0 plus 6. Remember, there's no 6 to it. So 0 plus 0 is 0. Of course, we talk about inverse properties, meaning we talk about this. So 1 and 5 are inverse of each other, 2 and 4 are inverse of each other, and 2 and 3 are inverse of each other. Right, and with that, we finish section 5.5. As always, thank you for watching, and see you in another video in Math 1332.